So this is the final in the point bake demos. What I've done for this example is I've exported from Maya using NCloth a basic cloth simulation animation. So what we've got is a model which is basically I think it's 32 by 32 grid. We then turn it into NCloth, we let it run, and it does a simulation. Fortunately, I can't show you because my license for Maya NCloth doesn't work at home. Weird Maya licensing. Anyway, I exported that when I was at work, and what we're going to do now is to load in the point bake data, but unlike in the previous version, we're not going to worry about a mesh. All we're going to do is worry about the data points and how we can use them. So here we go. In this case, we've got it being visualized just as a series of points, and we're accessing the raw data values. And this is the sort of thing you would do if you wanted to, for example, export something from Maya, use that to drive some further simulation, and then feed that data then back into Maya or something else, or expand on it, or create new meshes, or maybe export it to RenderMan for rendering, something along those lines. So again, we've got a basic NGL demo as I had previously. This time though, however, I don't have in my GL window a mesh. All I've got is, as you can see here, a point bake file. So in the initialized GL, I load in my animation data as I did previously. In this case it's called cloth.xml, setting it to frame, but you'll notice there's none of the meshing stuff that was there previously. Next, and this is where it differs in the drawing element, what I'm going to do just to visualize this is I'm going to draw each of the vertices as a point. So the first thing I need to do is to grab the animation data from the point bake class, and this is done using the get raw data from pointer, and in this case at frame, because I just want the raw frame data. So that's going to be a stood vector of NGL vectors. I'm calling it mesh, and I just call the anim data get raw data pointer at frame, passing in the current frame I want. And in this case I'm grabbing the size of that, which will tell us how big the data is. And now to visualize it, I'm just going to create a very simple vertex array. So in OpenGL, I'm saying enable client state GL vertex array. Then I'm creating my vertex pointer. I'm saying it's got 4 components. It's of type GL float. It starts at 0 in the array data I'm passing, and I'm passing in the address of mesh 0. Now, as this is a stood vector, stood vectors are guaranteed to be packed contiguously of NGL vectors. My NGL vector has 4 components, which again are packed tightly. What the vertex pointer will do is basically take that first memory address and run with it for the amount of data size we've passed it. So in this case I'm using GL draw arrays instanced arb. I'm saying it's an array of GL points. It's starting at 0. It's of size, which is basically the size of our mesh, and I want to draw 1 instance of it. And then finally I just disable the client array at the end because I've finished doing my vertex array drawing. So as you see, when we run this, every frame now it's just picking up the data, drawing it. Point size, let's just make the point size slightly bigger to hopefully be able to visualize that a bit better. See the loading. There we go. So now you can see those points are in there. So we can use this to drive some other future simulation, or anything else that you really want to do. You should also notice doing this raw method of it should be a lot quicker than the mapping. There you go. You can see that's incredibly fast when it's running there. The previous version was having to map the VBO and access that data, which is quite slow because we're mapping something, we're modifying and coming back. Whereas this is just creating raw data on the fly and just loading it to the GPU. It is relatively quicker than the previous version, which obviously has got a slight bottleneck with the mapping VBOs, which is a known slow issue. So yeah, you can see there it's running at quite high rates and quite well. So some of you for your master's projects need to do this, so hopefully this will give you an idea of how to do it. If you follow the links on the blog post, you'll see the rest of this code which I've uploaded, and hopefully this will give you ways of importing and exporting data in an easy way.